Welcome to homework.
We're given a graph, and we're asked to determine whether the given graph has an Euler circuit, and if so, to construct such a circuit. If no Euler circuit exists, we're asked to determine whether the graph has an Euler path, and construct such a path if one exists. So to determine if it has an Euler circuit, we're going to use a criterion from the book, Theorem 1. First of all, we see that our graph has 5 vertices, clearly greater than 2. Needs to be greater than or equal to 2, in fact. Now let's list the degrees of the vertices. So looking at the graph, we see that the degree of vertex A is 3. The degree of vertex B is 3. The degree of vertex C is also 3. The degree of vertex D is 2. And the degree of vertex E is 3. Sorry, the degree of vertex C was 3, not C. So it follows that the number of vertices with even degree appears to be 1. So not all the vertices have even degree. Therefore, it follows that the graph does not contain an Euler circuit. On the other hand, let's determine if the graph has an Euler path. To do this, I'm going to use Theorem 2. Well, we see that the number of vertices of odd degree is going to be 5 minus 1, or 4. This is clearly greater than 2, and therefore by Theorem 2, there is no Euler path as well.